Okay, on lesson 12.9, the last section of this chapter, we're going to talk about zeros of a function. I'm having to erase everything off the board so I have room to write. All of this is in your book in charts and tables anyway.
Mom.
Zeros of a function talk about where a function crosses the x line. These are the zeros of this parabola.
The zeros of a function are 0 cents and 0 points.
These are the zeros of that parabola.
What about the zero that crosses over
It's where my parabola crosses the x-axis. I call those the zeros, okay? And then where it touches the y-axis, that is another zero. The reason we call those zeros is because where this is touching my x-axis is at 0 on y, and then there's just something in x's place telling where it's touching. And where this is touching my y-axis, it's at 0 on x, and there's just a number telling it's where it's touching my y-axis. So that's why we call those the zeros of a function, because these are the places the parabola touches the x or y-axis on my graph. Where it touches one of those axes, there's going to be a 0 in the place of x or y, depending on whether I'm talking about the x or the y-axis. You can also call these the x and the y intercepts. This is where my graph intercepts the x-axis and the y-axis, and then the x-axis a second time. Yes?
Does it have to be like on the y, so it doesn't have to be like that's the vertex? Because if it's over at 3 places, it's going to intersect.
Right, if you have a graph that's has a vertex at 0, 0, it's probably not touching your either axis anywhere except at that spot. But we're talking about parabolas that have a vertex somewhere other than 0, 0. They're going to end up touching our x and y line. Okay? So, we can find the zeros algebraically.
Those are fun.
If you have a graph, you're just going to interpret your graph. You're just going to read the graph and find your zeros.
I wish that was all.
But if you don't have a graph, then you're going to find the zeros algebraically. How do we do that? We put a 0 in x's place.
I thought that was fun in the y-intercept.
And it's the same thing. The y-intercept is the 0 of a function.
Oh, well.
And we see when x is 0, then y is 5. Okay?
It says right here that the 0 in bold, it says the 0 of a function is the value of x in which the graph of the function crosses the x-axis.
Right. That's what I just said. Where it crosses the x-axis.
When you're trying to find the y.
We're trying to find the y also. Okay, right now we're trying to find the y-intercept, so we put 0 in x's place and it tells us the y-intercept. This was a function that was in standard form. What about if I have a function that's in graph form? I do the same thing. I put 0 in x's place. And I see when 0 is x, then the y-intercept is 3. So I can tell where these parabolas are going to actually touch my y-axis. Okay? So then how do I find the x-intercepts? Or the zeros of the function. Now first of all, look at this and tell me, how many y-intercepts do you see? 1. How many x-intercepts or zeros of a function do you see? 2. So to find the y-intercept, let's divide the board in half. To find the y-intercept, x squared minus 4x minus 5. To find the y-intercept, I put 0 in x's place. And I found the y-intercept. But to find the x-intercept, or the zeros of the function, I have to put 0 in y's
So
place.
if you find
Where is y in this function? It's the r of x.
Mom,
Yes?
so if you're finding it for y, you put it in x's place, and if you're finding it for x, you put it in y's place.
Right, but there is no y. So what is
R of x is
r
the
of
same
x
for
is
y.
the same thing as y. So I end up basically with a quadratic function equal to 0. Now I have 4 choices. I can take a root. No, not happening. I can factor. That'll probably happen real easily. X minus 5, x plus 1 is what I see. So that means x is equal to 5 and negative 1. So the zeros of this function are 5 and negative 1. If I wanted to write it as the x-intercepts, I would write it as a set of numbers like this. Okay? Now, turn to the next page and let's just interpret the graphs. By the next page, I mean page 523. Look at the 2 graphs. We have one y-intercept. Where is that at? Austin says he can't go because he's got too much college work to do. So I guess just you and Aaron go. Aaron will have to do his math for homework and get cash from Austin. He took cash out of my purse to get food, get cash from him. You and Aaron go get haircuts and tell Sandy I'll have to reschedule for Austin.
I thought you put Clark Kent on
Aaron, you
there
have to go
first.
right
I was
now
like,
to get a
what?
haircut. I'll finish your math with you later.
You
Okay,
finish my math for me as a kid.
no. Look at the first graph. There's one y-intercept. Where is our parabola intersecting the y-line?
At Jeff points.
1, 2, 3. At negative 5, correct. There are 2 x-intercepts. Where's it intersecting the x-line? Negative 1 and 5. So we could say the zeros of that function are negative 1 and 5. Look at the second graph. Where's it intersecting our y-axis? Negative 4. So the y-intercept's negative 4. Where's it intersecting the x-axis? At 2. Only one x-intercept on this parabola. So the zero of this function is 2. Okay? They say that even though there's only 1 0 on the second function, it only touches the x-axis in one place. We call this a double root since 2 factors produce the same root, because if you actually worked this out, you'd end up with probably like the square root of 4. So negative 2, positive 2, you end up with a binomial squared. So they call that a double root. I don't know if you're going to need to know that in any of your problems or not. Okay, let's look at example 3. We have 2 functions. One is in graphing form, one is in standard form, and we're told to find the zeros. When it says find the zeros, that's the same thing as saying find the x-intercept. How do we find the x-intercept? We put 0 in y's place. Let's look at the first one that is in graphing form. Don't let me I'm going really fast and I don't have that magnified, so don't let me do any thing wrong, get any of the symbols or anything wrong. So P of X is the same thing as Y, so my 0 goes here, and I actually now have to work this out, okay? I will be able to take a root of this if I move this 6 over here like that and change its sign. Then I can do a square root of both sides and get x minus 1 equals positive or negative square root of 6. So x will equal, move that over here, 1 plus or minus the square root of 6. I obviously need decimal equivalents when I'm finding the zeros because I'm telling the point at which it would cross the axis. So I see that it's going to cross at 3.45 and negative 1.45. Now this equation here,
I see.
q of x, this function, is in standard form. Same thing, I put a 0 in x's place, and I now work the function. I can use quadratic formula if I have that programmed into my calculator, or I can try to factor or complete the square. This is not a problem where I can take a root because it has all three terms there. We can't factor into 4 and 1, and we can't factor into 2 and 2. So probably quadratic formula would be the best way to work that. That's exactly what they do in my teacher key, and this is what they come up with. I don't have quadratic formula in my
I call it
yeah,
just
and I don't
Mine
want to
says
work
like
it
a
all
7 and-
out on the board. I'm
Yeah,
getting
it says
1
that.
plus or
It's
minus the
zeros.
square root of negative 15 over a 2. And I can say there are no real zeros because I have a negative in the discriminant. And I cannot have a negative under a radical.
Right.
Okay? Does that make sense?
Yes, ma'am.
Okay? If you look down under that, there are graphs that correspond to these two equations. And you can see where this one here is graphed. It actually does cross the x-axis at 3.45 and negative 1.45, basically 3.5 and negative 1.5, pretty much. And you can see when this one is graphed, it never touches the x-axis, does it? Look at that graph.
Nope.
That's why there are no real zeros. Did you look at, which graph am I talking about?
The second graph on the temple.
Yeah, he's just agreeing with me though, but not looking at the book. So I'm making sure he knows what he's agreeing to.
This one?
That one touches the x-axis. Yeah, that one does not touch the x-axis. That's why we came up with a negative and a radical, which means there's no real zeros because it never even touches the x-axis. And that's what zeros are. That's what the term zeros means. Example 4, they give us a quadratic function, tell us to find the y-intercept, the zeros, the vertex, and graph it. Okay? So, pretty complicated instructions there, multiple instructions. Let's work this out. I have, let me make sure I'm still recording. Not sure how much space I've got. I have f of x equals 3x squared plus 8x minus 3. Now, I've got to do several things. One thing I've got to do is find the y-intercept. How am I going to do that, Jax?
Find the line is changed.
What am I?
The
how-
x's into zeros.
I'm going to turn the x's into zeros. Correct. Okay, so I know my y-intercept is 0 and negative 3, right? Okay, now I'm also told to find the zeros of this equation. How am I going to find the zeros of this equation?
Set the function equal to 0.
I'm going to set the function equal to 0. Okay? I have multiple ways of solving this. I could factor. I could complete the square. I could use quadratic formula on Patty's calculator. They factored it for me in my book, so that's what I'm going to do. Because that makes it easy for me.
Too many numbers. No.